Question 2. A potential difference of 8 volt is supplied across a 20 degrees Celsius iron wire with a uniform cross-sectional area of 0.08 mm square and length of 0.5 meter. So we have to determine the resistivity of the iron wire if the current flowing through the metal wire is 1.2 ampere. And after leaving the circuit closed for an hour, it was found that the electric current decreases by 0.001 ampere. So we have to determine the change in temperature. Okay, so determine the change in temperature. Okay, so that is question A. So given is 8 volt, and then the temperature of the wire is 20 degrees Celsius. The area is 0.08 millimeter square, and length is 0.5 meter. Okay, so question 1, remember resistivity is R A over L. Okay, but we do not have the value of resistor, so this is also equal to V over I. We get this from V equal to IR. Okay, so substitute that into here, so we'll get VA over IL. So this one should be equal to 1.06 times 10 negative 6 ohm meter. Okay, and then question 2 pula, so the circuit is closed for an hour, so the current decreases by 0.001 ampere, which is basically 1.2 minus 0.001 gives us 1.199 ampere. So the original current is 1.2 ampere. Okay, that is from Roman 2 lah. Okay, so the alpha is also given, which is equal to 0.005 degree Celsius per degree Celsius. Okay, so from here kamu boleh guna the equation R equal to R naught 1 plus alpha delta T. Okay, so this is the variation of resistance with temperature punya equation. So again, we do not have the value of resistance, so we are going to use V over I. V over I naught 1 plus alpha delta T. So you rearrange for delta T, so you should get 0.167 Kelvin as the answer. Okay, alright, so question B pula, a wire has a resistance of 8 ohm at temperature of 70 degrees Celsius and resistance of 4 ohm at temperature of 20 degrees Celsius. So calculate the temperature coefficient of resistivity of the wire. So for this one, you are going to use the same equation. So delta R, this is going to be equal to alpha R naught T minus T naught. This is from this equation as well lah, except that this one kena masuk darab dalam, and then this R naught here will be di sini, so dia jadi R minus R naught. This is basically delta R. Okay, alright, so then you'll get 8 minus 4 equal to alpha 470 minus 20, so you should get alpha equal to 0.02 per degree Celsius as the answer lah. Alright, okay, so that is the solution on question number 2.